Okay, guys, this is the last video of this series. I hope you liked it so far. Just something that popped up in my mind was how can we determine the reactions of an imposed displacement? So we usually do this type of procedure whenever we are assessing the performance of a member. We do this as like a test in a structure for, let's say, we want to assess the capacity of a structure based on the properties of the materials. So we know the section properties, and we know the span, we know how much deformation we have imposed, and then we can determine on the strength. Okay, so this is a very standard procedure that we usually do in the industry. Let's pretend that we have a cantilever 6 meter span. Okay, okay, 6. And let's pretend that this cantilever beam is fixed on the support like this, okay? Also, let's pretend that this beam is made of steel, so we know its properties, and we know the section properties, which is this I shape here that we have used in previous lessons. And I want to see how much reaction load will this configuration impose if I push this node of the far end of this beam, let's say 5 millimeters, okay? How much load would have been transferred to the support? And this is quite simple. We go into the support condition, and here, let's ignore this for a moment. Let's say that this node here is going to have a prescribed displacement. And I want to impose in this prescribed displacement on the y direction. Let's say it's going to deform towards the bottom minus 5 millimeters, and then I apply. So what this is doing precisely is creating a boundary condition, which is as an imposed displacement. Okay, the scene of the support does not give you any supporting conditions. It's just the way the software uses to describe this is happening. And then when I apply the results, look how interesting this is. The deformation is in fact 5 millimeters, and look at the direction of it, okay? So it will give me around 1 kilonewton on each side and 10.6 kilonewton meters, okay? So this is what this situation does, okay? So this is quite interesting. Then you can see the flexural moment of the creation, okay? And you can also see shear and also the, well, axial load, which in this situation did not have, okay? So this is an interesting way to impose deformation in a structure. We can do the same thing, for example, I will just erase this. And let's say we have a 2-bay frame again, like this. And we want to, let's pretend that we have fixed conditions like this. Okay. Oh, and we don't have prescribed displacements here. Okay, all right. And then let's just say it's also a steel structure, also with the same profile that we have used previously. And also that we want to push the structure horizontally and see how much stress and forces will arise from the situation. So it's the same procedure. I'll go into the supporting conditions. I will apply a temporarily supporting conditions, and I will prescribe a deformation, let's say, of minus 20 millimeters. Okay, so I want this whole structure to be pushed on the top of it by 10 millimeters. And then let's see the reactions, okay? So look how what it creates, okay? So again, the Ftool does not calculate the structure self-weight. This is something that you have to do by yourself. And this imposed displacement generated in terms of actual load, 64 kilonewtons on the beams, the top beams. Shear create also shear, and flexure also creates fracture. Okay, so this is again the potential of the software. You can create infinite boundary conditions if you may. And this software you can calculate nodal forces, um, end moments, linear forces, thermal loads, imposed displacement. You can also create train loads for traffic conditions. So the F2, even though it is a 2D structural analysis program, its features is packed full of potential. And many of the engineers in my country, we actually use F2 a lot to design bridges, for example, and design smaller structures, or to assess specific structures and seeing the behavior of them whenever you have these different boundary conditions. So if you didn't know the software already, the link to download is quite simple. It's free again. You can use this as your disposal. Usually undergraduate students, if you can manage this type of software, which is quite simple, is the main interest to the later softwares that we usually use in the industry that are more complex, but they're all based on the simple ideas: boundary conditions, geometry of the structure and the specimens, the members, and their mechanical properties. The rest is pretty much analysis. Okay. So again, if you like this content, please like, share, and subscribe. You guys help me a lot with this, and I hope you enjoyed this series. Until then, next time.